Hey, and welcome back to my channel. Battery in the Bluetooth remote's gone flat. It's a bit annoying. These things all seem to be chewing batteries a lot at the moment. Maybe it's because they stay connected on Bluetooth or something. I'm not sure. I have to check that. But the Sony, it goes through batteries all the time. Like if I leave that in there, by tomorrow it'll be 50% depleted. Not sure why. Today, hopefully, we're not going to have any interruptions. I've got the DC power supply backing up the camera, so that's going straight in, and I've got the 128 gig SD card in there. So, welcome back to my channel. I hope you're enjoying this. Last time, you may remember, I found that there's a PNP TO220 transistor and a 7808 voltage regulator and a track blown on this PA board. So you might notice I've got the gloves on today. I'm got them on because there's a lot of heatsink compound on here, and I have to say heatsink compound gives me the heebie-jeebies. I know a lot of the stuff that I've played with over the years predates the 70s, and they certainly used a lot of beryllium oxide before then. You don't want to be touching beryllium oxide. So anyway, I don't know the history of this heatsink compound, so I think you can't be too careful. What I'm going to be doing is pulling this PA board, and we'll start simply by disconnecting all of the... I'm not sure if there's anything I can do to give you a better view down here. Let's actually start with that. Hopefully you can see a bit more. There's probably no need to zoom in. It's just me pulling connectors off at the moment, and I'll keep you updated as I go. So I'm pulling off the connectors, the coax from the driver, and the output to the low pass filter board. Going to Phillips head screwdriver happening, and yeah, it's a long one, but you can see better what's going on in there. Pulling these screws off. So basically I'm going to carefully remove this PA board, and it's a bit of a pain because you actually have to pull all of the transistors off that hold the all of the screws that hold the transistors off. Here's that annoying connector. I don't know what that does, why they bring the TX 13 volts out, and well, there's your problem. Have a look at that. Don't know if you can see that. I'll get some better lighting actually. I had not noticed that earlier. That probably answers a lot of questions. Can you see that charring on that top left hand, right hand, yeah, I'm looking at it from your side, left hand pin? That is the one that takes the TX volts back out from the radio. So that's really been cooked. Not a little bit. That's like catastrophic. That's like lightning kind of stuff. So interesting to say the least. Yeah, remember I was hypothesizing that somebody probably put volts up that track. And that may be a sign of what happened. I mean, it's almost... To generate a spark like that... with that amount of metal vaporization, I'm almost going to say you have to put mains up the thing. I certainly have seen that happen with mains connections, so I'm just clarifying which pin this actually is on here. Yeah, so that's TX 13.8 volts on the radio side, not on the PA side. So that was all actually connected together. So in the process of that track getting vaporized, it's taken out the 7808 and the PNP transistor. Wow. Well, yeah, looking at that, it's either, yeah, like I said, the 12 volts has probably been driven in there backwards at an absolute minimum. And I'm thinking it may have been actually something more grunty than that they've put into there. I've had a FT-857, one of the ones I repaired, I won't say recently, but probably the one before the one that's sitting here. It definitely had 24 volts up it. Somebody just installed it in a truck without thinking. I don't know why people do that. 24 volts straight into it, blew the PA transistors and all of the voltage regulators. Yeah, not sure why they don't have a bit of superficial protection, voltage protection in them. I thought this actually did. I can't remember now. We were looking at those funny diodes and everything else that allowed the relay to turn on. Basically, if you're ever going to design something that people have to connect to power, it's a good idea to put a main input relay switch and a way of activating that in such a way that if the volts applied is higher, it keeps it turned off. So there we go. We've got all the connectors disconnected now. Can move this around, get a bit more space over here, and let's start pulling the rest of these transistors, screws out, and see how easy it's going to be to get this board out. Now, looks like, yeah, all of these, actually not all of them, that 7808 is screwed to the chassis. The other two transistors here are not screwed to the chassis. There's one weird folded metal thing here that's screwed to the chassis. Just checking that I'm not doing something stupid like filming this in slow motion or anything. I'm always paranoid now. I've done so many videos now that I haven't been able to use because I've accidentally put the camera for some reason into a slow motion mode, which is actually a good thing now with this. Where did I drop that screw? Oh, it'll come up shortly. I've got a mini rig thing for this camera, which is a bit of an aluminium chassis that you can mount stuff on. And the really good bit is it partially obscures the movie / slow motion button, so I'm not inadvertently clicking that all the time, which is yeah, really good news. Yeah. Now I'm near the gunky bits, so let's try. Just be careful that I don't get heatsink compound everywhere. Now these screws are different. I'm just going to get a container to put these transistor screws in. I like these little takeaway source containers. They're great for putting all these little screws and stuff in. And just so you don't lose them. I used to do a lot of motorbike projects like this where you'd go to a swap meet and you'd pick up a Bitzer, a basket case, usually a milk crate full of motor parts and a frame with or without wheels, and they'd be great. And usually the person selling it wasn't the person who took it apart, they're just cleaning out the shed, and they didn't realize that the jar on the shelf with all the nuts and bolts and screws in it belonged to the motorbike. So there's all these lonely jars of nuts and bolts and screws around the world that are missing their motorbikes. And it was always fun to try and work out what screws you needed and where you'd get them from so that you could put that bike together. Because generally the whole bike was there, and they'd usually pull them apart because they thought something bad was wrong with it, but it ended up being something simple like a block jet and a carby or something. But no, they had to strip the whole lot down. And they're good fun. It's a good learning exercise. I used to love them. They're like jigsaw puzzles and you don't know how they go together. I mean, after a while, you start to know exactly how Yamahas or Hondas of a particular type and a particular era go together. And it becomes quite easy. But I tell you, the first few that you do, it's good fun because there's often one spacer in the gearbox that separates a gear, and you don't know if it goes on the left or the right side of that gear, and you don't really know until you take it for a test drive and it seizes up on you, just locks up the back wheel, because that one spacer allowed 2 gears to engage at the same time. So there's always funny little things like that, and they're little tricks to look for. And I recently repaired the gearbox on my Ford Ute, and that was a bit of fun, managing and getting all the spacers right, because the spare parts pack came with shims and stuff, and I'm not sure where they actually went, so I just ended up putting it back together exactly the same as it came apart, and touch wood, it hasn't given me any problems. Funny thing is, that 4-wheel drive Ute, it's got the transfer gearbox on the end. The gearbox still has exactly the same parts as a 79 Cortina gearbox, the 4-speed gearbox side of things. Then they put a overdrive unit on the back of that for the 5th speed and reverse, and then on the back of that is the transfer case for the 4-wheel drive. But the internals, believe it or not, are exactly the same. That actually surprised me. Surprised a lot of people actually at work when we were talking about that. Now there's a mica capacitor here that's giving me a bit of trouble. Try and clear that without breaking it. Leave that one for now while I work on the others. The idea is to see if I can just crack that screw loose. Actually, I'm going to see if I can get in with a narrower screw and a pair of pliers to get the torque on that, I think. Yeah. The trusty old vice grips on a small Phillips head should be a bit safer on that. Here we go. There we go. That's all we needed. Just got to crack that that initial torque. That little screwdriver gives me enough clearance to get in there and not damage the silver mica capacitor. They're a pain to get, and they're not cheap. Incredibly good for ATUs and stuff, because they're low frequency. They're low loss at high frequency. Okay, so I think that. Have I been putting the screws in the wrong place? I think so. I think that... still one more here. Yep. That's the last of them. I think. Now I've got to be careful with these transistors. They're generally stuck down, and the problem is you can actually, if you're not careful, you can pull the ceramic and the transistor off the heatsink. But no, looks like this heatsink compound has dried out quite a bit. There we go. There's the underside of it. We've got this elephant hide insulation there. Looks like it's had a bit of moisture in here. Something's been spilt in the back. Doesn't look like it's much of a problem though, actually. Not excessive amounts of heatsink compound in there, which is good. You can see where there's been a little bit of moisture on here, but certainly nothing that I would call a problem. So that's the bottom side of the board. Actually, I can get some light on there. Yeah. So also, while I've got it apart now, I should be able to show you where that track was fried a bit better in there. I'm going to zoom in. Now, is it going to focus on here? Yes, it is. And right in. Get the angle right on this connector there, where the finger is there, where that number. Still focused? I think we're still focused. Sorry if it's not, but right there, above that, below that connector, there's the fried track. So there's going to be damage downstream from this. That's guaranteed. I need to see what things it went into. it went to the output connector that went to the relay switching for the external linear amplifier. And it went to a few small other things. So I'm suspecting there's probably one more NPN transistor further down the line on the RF board, which is cooked. And that's why I'm not getting any LO out when I transmit. I'm just out of shot now looking for a toothbrush to clean this board up a bit with, but I can't seem to find any just right now. I usually have one or two toothbrush around, but oh well. Okay, so I'm hoping that this hasn't done too much damage to anything else on this board. So I'll pull that PNP transistor off this board, get the soldering iron heated up. Yep, that's heating up. A bit of space over here. So I'm replacing the PNP TO220 with a TIP32, which has got similar characteristics, a little bit less current gain, but I think being a more modern transistor, that's probably not going to be an issue. So these are nylon screws with some with varnish on them, so I need to clean that off, otherwise it's just going to twist the head off that screw. That's a smidge annoying. Why do they do that? Okay, I'm gently winding it backwards and forwards to clear that varnish off that screw. I had a box of nylon M3 screws somewhere, but I'm finding I don't have that much of this stuff here anymore, and there we go, I've twisted the head off anyway. Bugger. Yeah, bloody thing. Oh well, it's a little bit annoying. It's also annoying because now I've got to get it out the other way. Yeah. So that, I don't know why we need a nylon one actually on there, and I'll probably just put an M3 in there because there's no tracks on the underside of that board. So there's a low likelihood that I'll damage anything by putting a plastic one in there. But that also said, there's no heat sinking on that thing either. It's in saturation. I probably won't bother putting anything in there straight away to hold it in place. Okay. Now, the easiest thing to do with replacing transistors, you know it's cooked. So you just do that with the side cutters, cut it out, and then desolder each of them separately. So that and that. And now this one though, this was connected at 7808. That was screwed to a heatsink. Although not in a way that it's going to be thermally conductive, that's for sure. Okay, so fired up the soldering iron. Now my technique usually for pulling pins and stuff out is put a bit more fresh solder on it. American solder. Don't ask me why. Salmon we say normally, but we say solder. So I'm going to put some solder on these pins. I wish I had my magnifying glasses on. Eyesight's not what it used to be. So beauty with these older radios is too that they're still lead solder, so you've got to be cautious, as with all things. But you don't. They just resolder so much easier than the new lead-free stuff, which is like it forms. There's a word for it where it once it melts, it changes its once it solidifies, it changes its melting point, and then you can't. You see, the grounds are always a pain. I've got one of those sucky things somewhere. They actually work quite good for this kind of stuff. That just they're spring loaded, and they draw the solder out. Great. So the only one that needs a bit of cleaning up for that one is the ground pin, which is to be expected. And where's the other transistor? Those three there. Again, I'm not running very hot on the soldering iron. That claims 324. It's a bit higher than I normally solder at, but that's because these are big transistors. Ah, sweet, that went well. There was the screw that I thought I misplaced. And that pin there. So actually, that didn't work as good as I expected. Those pins have been swaged by the looks of it. I'm in two minds about how best to fix that cook track. Whether I think I'm just going to varnish that track and just put a nice little track on the a wire on the other side to sort it out. I think that's going to be ultimately the nicer solution, because to repair, if I'm going to do a proper track repair, I'm going to need to actually remove that connector, and I don't want to do that. Beautiful. So we've got three clean, just up here, here, and here. You can see they've been removed. Yeah, so the new ones are in a little baggie here. Yeah, so it's a bit sad that there's still other stuff on the other board that's going to be cooked, because I can't power this thing up straight away. Just let me get along those pliers so I can bend these legs. Bear with me, I have misplaced the small electronic long nose pliers. Apologies for that. Just going to have to use normal pliers. Actually, I found a shifter spanner actually works good, but I'm just looking for, still looking for the long nose pliers. I really thought they were here. Now I can't find them, so I'm just going to use flat nose pliers. And I'm going to put that there, eyeball it, bend that one like that, and one the same, and center pin. So that's the 7808 going in. Difficulty with those holes a bit. Okay, just got to make the ground one go in. That one's going to be the toughest one. Alright. That the ground pin is being a bit of a nuisance to get in. Okay. I think looks like that one's going in now. Yeah, this one, because it was the ground, it has a bit of an issue with thermal conduction. These boards were all done on a wave, industrial size wave soldering machine, so the whole board is brought up to temperature. Everything is preheated, then it goes over and everything's just soldered over this wave of solder. And that really means that there's no thermal relief or anything. I didn't think the concept of thermal relief existed in the days when these things were being made. Didn't need it. Really didn't need it. This board was actually tape and film, so that's how they did them back then. Yeah, I still did a few of those. I remember reworking some of the Kodan radio designs. Just pulling through the other two pins. Yeah, okay. Soldering it in, and that's the 8-volt regulator in place. Beauty, and we cut the pins off. And now the transistor has to have the same thing done to it, except this one's going to be a bit easier in that hopefully the holes are going to be a bit cleaner, and I don't have to melt that middle one to fit it in. I should probably, if I do more of this stuff, if you guys are interested in this kind of stuff, I will make up a jig with a camera looking down at what I'm doing. Just wondering where we're at now. Okay, we're getting up to 30 minutes. This is getting a bit long, but I mean, I'm giving you the dirty on everything I'm doing on this. So I'll keep going like this. If you get bored, just fast forward. Yeah, so just updating. One of those isn't completely clear. better. Much better. I don't know if these new transistors have got fatter legs or what the go is. They're not going through these holes as easy as I would expect. It's also hard with these gloves. It's funny. I've never look. See, if I wouldn't have the gloves on, I'd get this heatsink compound on me, and I just don't trust it. I just really don't. I wish when I was younger somebody had told me, "Hey, that stuff's carcinogenic. Keep away from it." But anyway, then again, we were also playing in asbestos dust because it sparkled when you threw it in the sun. Hey, so there you go. The things we did when we were kids. You have to wonder why half the people my age are still around. Hey, probably not actually. Real difficulty getting this guy into those holes. Yeah. No. See, this transistor, the pins aren't as pointy as they were on the voltage regulator. So I'm almost tempted just to cut them off and solder them to the top. Okay, I'm going to see if I've got solder in there that's causing me problems. No, I think literally these pins are fatter than the one that was in there. So, just going to cut them off and solder them to the top of the board. There we go. It's not like it's going to be a mobile application. There's going to be a fatigue vibration risk on this. Right, that worked well. I will touch it up on the other side just to make sure that I have good conduction through. They are plated holes, so the solder will wick through. And there you go. So those guys are all back on there now, fully set up. Right, so the last thing I need to do is connect that pin 4 on that connector to the collector line on that transistor, I'd say. Runs up there, comes out there. Nice. Okay, so I've got a pad right here which goes there's a pad right there that goes through the hole and onto the other side, and just got heatsink compound all over my mat here, which is a pain. What I'm going to do, I had some of that little wire I was using to jumper the other stuff the other day. Bear with me, I'm just going to get a little bit of wire. a lot of stuff now is I get out of China is really, the wire connectors are really good, and I'm buying cheap junk just to pull the connectors off things. These wires are silicon insulated, which is just beautiful to solder because you can't melt the insulation on it, and it makes life so much easier when you're soldering things, and it's nice and flexible, and it's a real neat finish. So yeah, getting that wire is hard. It's expensive to get here in Australia just on rolls like hookup wire. So yeah, if you can get it, keep the stuff. Don't throw any of it away. It's really nice stuff to work with. Right, so run it up there and across there. So that's exciting. That's the first fix on this board, I think. We still don't know if the PA transistors are cooked. We won't know until later, until we apply drive. I've got a nice signal generator which we could actually use, but I don't have it here. I need to go to my mate's place and get that. Okay. So I've just jumped it underneath like that. Don't know if you can see that there, right there. Yeah, there. So that's that just replaces that burnt track. The rest of the track on the other side is still in good enough condition that it's not going to short anything. And so that's. I'm just going to put this back on like this. If I have to pull these off later to put the mounts underneath, I will. But right now, I just want to see if I can get this going. So get the heatsink, fresh, new, probably just as bad heatsink compound. It's locally sourced. Actually, this stuff says somewhere that it's beryllium free. I think I was interested in seeing that. So there we go. Beryllium free heatsink compound. Batch number. Yeah. Okay. So we will just put. Oops. Wow. Comes out a bit much there. All of those, and put this PA back into here, set it down, give it a nice plonk like that, and I'm going to put the screws back in. I'm not going to put the PA transistor screws in because they're the fiddly ones, and I'm not going to transmit long enough for them to heat up, because I'm not even going to put them into a I'm not even going, yeah, I don't have the dummy load here, so I don't know why some of these screws are a little smidge different, unless that was the one that went in there to screw down that 7805. And then there's one long one and the other short ones. That short one went in there. There's two short ones. Oh yeah, clunk. That little clunk was a rubber connect. These little rubber blocks that hold the power connector in. One more transistor. I mean, one more. What am I saying? Transistor. One more. Oh. Am I one short? And that other short one was the one off the power connector. Yes, yes, yes. Rightio. Well, I'm not going to put that one back in yet, although I'm still one screw short, and it may have been one of these. 1, 2, 3, 4, 5, 6, 7, 8. No, not one of those. So yeah, have lost one somewhere, but that's enough for me to power this thing up and at least see if we're getting all the bias voltages and everything happening in this thing now. It's a bit exciting. So put this all in, connect everything back up again. It's exciting. That's the one with the TX, which we're going to hunt on the RF board. It's unfortunate they've put two headers there next to each other, which are exactly the same 2-pin variant, which is a bit of a pain. But I think I know which one went where. Okay, it's all done. I'm gonna there we go. Power that up so we can monitor the volts on things. Okay, so that's everything together now. Right, so moment of truth. A bit exciting. Okay, we don't have that connected yet, so we'll put that back in here and put that 2-pin header there, but I'm not going to screw those down. Negative on there, 13.8 volts, positive on there. All the currents and everything are still good. TX is low, VTX, yay, 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 yay. We've got 2, 4, 6, 8, 10, 12, 13.8 VTX. So that's working on here now. 2, 4, 6, 8 volts on the bias. 0.6 volts. Yeah, 0.7 volts on the pre-drive. It's a little bit high on those transistors. I think what I just want to do is, I'm not sure if my current shunt is working in the multimeter. What I'm going to do, you can see this one, but it's not an important one. What I'm going to do is desolder the bias current loop and see if those transistors are sinking any current, because I'm not seeing what I would expect when we're keying this up. I'd expect those transistors to have a bit of to draw about an amp, I'd say, when this thing powers up, and it's not. So that to me indicates that probably these guys are cooked. Okay, so multimeter on, amps DC. Alright, turn it on. Connect these two up. I should have alligator clips to click on there. Yeah, nothing. Although I'm not sure if that's because my multimeter's broke. Oh, hang on. I've done this before, I forgot. Old school multimeter. Interesting. Okay, 130 milliamps. 130 milliamps from a PTT. Okay, I'm going to have to check what the setting actually is for that. They might be okay. They might be. So hey, that's it. I've done what I can right now. If I have to, I'm going to have to replace those power transistors. So I'm not going to screw them in just yet. but the rest has been fixed. Now we turn the radio over and I start looking at the RF board, what's been broken on there, because that TX line has been overvolted or reverse volted. So there you go. I hope that wasn't too boring, but that was tonight's project. I do this, I come out here, that's my hobby. This is the latest one. So yeah, I hope you learned something. If you got any questions, please leave them in the comments. I really would like to hear from you. I'm happy to answer all your questions. This is what I do. I love fixing these kind of things. So if you like that, hit that like and subscribe button. And thanks for watching. I'll see you again next time. Bye for now.